Good morning, learners. Welcome to the lecture series. Today we have a very important topic for the researchers dealing with quantitative approach in their research undertaking. So today we are going to discuss about measures of central tendency. Under measures of central tendency, we have mean, median, and mode. Let us have an introduction about what is a central tendency. In statistics, a central tendency is a central value or a typical value for a probability distribution. That means in a probability distribution, a researcher is expected to calculate a value which serves as a central value or a typical value. According to Simpson and Kafka, a measure of central tendency is a typical value around which other figures gather. That means it is an average. So here, central tendency is occasionally called as an average. So as we are discussing about central tendency, we are supposed to discuss about arithmetic mean, median, and mode. In this particular lecture, we have in-depth discussion about arithmetic mean. So in the following lectures, you may learn about median and mode. So let us give some background about central tendency before we start mean, that is arithmetic mean. So here measures of central tendency, they are defined for population as well as a sample. That means if the researcher wants to calculate the central tendency for the population or a sample, it is possible. Moving ahead, measures of central tendency is important because it helps to find a representative value from the distribution, and it helps to make concise data, and further it helps comparison and is very helpful in further statistical analysis. So these things you'll understand while we are discussing some examples. I'll be clarifying these points one by one, and you'll realize the real meaning of these points when we take an example. Let us start with the mean. So here, mean of a set of values or measurement. So what is a mean, or how to calculate a mean? That is very important here. So here, it is a sum of all measurements divided by the number of measurements in the set. So here we have to sum all the measurements, and we are supposed to divide by number of measurements in the set. So still, if the students are not clear with what it means, we have examples to clarify these things. So here, mean is the most popular and widely used. That means when we talk about central tendency, most of us, we talk about arithmetic mean. It is sometimes called as arithmetic mean. So here, mean can be calculated for any set of numerical data, and in a particular distribution, we have only one mean. So that means there can be more than one mode in a distribution, but here, as far as mean is concerned, we get only one mean. And mean is the most reliable measure of central tendency, and I would say it is widely used by the researcher because it takes into account every item in the set of data. That means it includes every item in the set of data. So let us start with mean. So as we have already discussed, that mean can be calculated for sample, mean can be calculated for population. So here the similar things are discussed. Sample mean is represented as x bar. That means if you're drawing the mean from the sample, we call it as a sample mean, which is denoted by x bar. So how do you calculate sample mean? It is sum of all the values in the sample divided by number of values in the sample. So this is the formula here, which says x bar is equal to sum of x divided by n. So slowly you will understand what is x bar, what is sum of x, and what is n. Okay, let us not jump to the conclusion. Similar thing, suppose if you want to calculate the mean from the population, that is called as population mean, and it is represented by mu. It is represented by mu, and population mean can be calculated. There's a formula for that, which says sum of all values in the population divided by number of values in the population. That means if you see both the formulas, sample is replaced by population, and here mu is equal to sum of x over n. Okay, so our prime focus of today's lecture is to discuss how to calculate mean for single series, discrete series, and continuous series. So we have an example for each one of those items, right? Let us see one by one. Let us start with single series. So let us focus here. We have an example which says that a sample of 5 executives received the following bonus last year in $1,000. So there are 5 executives here, and their bonuses are given here. So these bonuses, they are in $1,000. That means executive 1, he got 14,000 US dollars as a bonus. Executive 2, the second one, he got 15,000 US dollars. The third one got 17,000 US dollars likewise. So we have 5 executives. We have their bonuses here on the display. So how to calculate when the distribution is in a single series? So solution is here. X bar is equal to sum of x over n. So x bar is nothing but the mean. Sum of x means all these values are to be added. That means 14 plus 15 plus 17 plus 16 plus 15, right? So x bar is the sample mean, and sum of x is the sum of all values in the sample. N is the number of values in the sample. So when you add all these values, like 14 plus 15 likewise, you get sum of x, and n is nothing but number of values. That means how many people are here. So there are 5 people. So if you present here in the form of a formula, we can see here that x bar is equal to sum of x over n. So we have added all the bonuses of the executives. We have divided it by number of executives. So it says the average bonus of all these 5 executives in a particular year is 15.4 thousand US dollars. So this was a very simple example. If you want to practice, you can just change the figures and you can practice. Moving ahead, let us have an example of discrete series. So the example which you can see here is for discrete series. So marks and number of students are given here. So the marks of the students and how many students they got those marks is represented. Like 25 marks they are received by 20 students, 43 marks they are received by only 1 student, and 38 marks they received by only 4. Likewise, we have 100 students. So total number of students they are 100. So marks are called as X. Number of students they are called as F. F is nothing but frequency. How many times? 25. How many times? 20 times. The number of students they are 20. Okay. So moving ahead, we have a formula for this. Students are supposed to remember the formula. So if you remember the formula, things become very easy for you. So here x bar is equal to sum of fx over n. So just see the formula and calculate only the thing which is required in the formula. So in the formula, we require sum fx. N is already known. N is number of observation, that is number of students. Number of students, they are 100. Sum fx. So f is there, x is there. So we will draw one more column where we are going to calculate fx. That means you will multiply x with f or f with x. It means the same. So here it's done for you. Yeah, if you check here, if you multiply x with f 25 times 20 is 500. Likewise, we have done. And at the end, if you see 2870 is nothing but it is the sum of fx, right? fx1, fx2, likewise. At the end, we are going to add all the values in the fx. We call it as a sum of fx. Sum of fx is 2878, and number of students, they are 100. So now your job is to calculate the mean for the given observation. See here, sum fx is 2878, n is 100. So x bar is equal to sum fx over n, that is 2878 divided by 100, that is 28.78. So that means the average marks scored by students in a particular quiz is 28.78. That is our mean. So that is the conclusion, right? Now let us move to the continuous series here. So the example which you can see here on the display, it's an example for continuous series. So continuous series here, x values, they are represented in class interval. In class interval, as you can see, 0 to 10, 10 to 20. Likewise, f value as it is. So x, as it is in class interval, it is also called as continuous series. It is also called as continuous series, and it is also called as grouped frequency distribution. So it's called as group frequency distribution. So what I suggest my students is examples will be given to you. You are supposed to calculate. You are supposed to calculate only what is required in the formula. So here, when you see the formula, x bar is equal to sum fm over n. So if you compare the formula with the previous one, in discrete series, the formula was x bar is equal to sum fx over n. So here we have only one difference. Instead of fx, we are calling it as fn. Because if you see here, can you multiply f with x? It's not possible, right? You can try in your calculator 0 to 10 times 2 or 10 to 20 times 5 is not possible. So what we do, we are going to find m first. M is nothing but the mid value of the class interval, that means x. If you see the first one here, x is 0 to 10, which is a class interval. So we find the mid value. So what is the mid value of 0 to 10? The mid value of 0 to 10 is 5, right? So under m, we are writing the mid value 5. The next one is 10 to 20. 10 to 20, the mid value is 15. Then if you see 20 to 30, the mid value is 25. If you see 30 to 40, the mid value is 35, and so on. So here our columns are ready. Like f is there, like number of students, they are 20 here. M is also calculated. Now what is required in the formula? We require sum of fm. So f is here, m is here. Just you are supposed to calculate fm, that means f times m, that means 2 times 5, 5 times 15, likewise. So it's done for you. You got the ready-made answers here. 2 times 5 is 10, 5 times 15 is 75, likewise. So when you add all the values of fm, we get the sum fm. So sum of fm is 550. So as required in the formula, we need sum fm over n. So our sum fm is 550 and our n is 20. Let us do it here. You can see here to the left hand side corner in your bottom. Here, yeah, some FM is equal to 550 and N is 20. So when you try to substitute, yeah, it's 550 times divided by 20, it is 27.5. See, as easy as that. Just see the formula, find only what is required in the formula, and you get the answer. So here, X bar is equal to 27.5. So which means the average marks scored by students in a particular quiz is 27.5. Okay, so this is the conclusion. So what is more important here is I have written the formulas for single series, discrete series, and continuous series. Students are expected to note down these formulas so that if you know the formula, you can easily calculate. So we are done with mean with one example in each series, right? You can practice as many examples as possible. Try to practice in a group, right? And our next presentation will be on median followed by mode. Okay. If you have any questions, any doubt, or if you want to learn something else in statistics, you can write down in the comment box. And please try to like my video if you like it. If you really like it, you can press the like button. You can share if your friends they need to learn about center tendency. And please subscribe so that the following lectures are notified to you. Okay. Thank you, one and all. See you in the next video.